Monitoring your broadcast workflow pays off. Hello and welcome to episode 3 of Connecting OB, discussing the challenges of outside broadcasting. So first, let's define what a workflow is. A workflow is the sequence of processes through which a piece of work passes from initiation to completion. So in terms of an OB, and broadly speaking, we're looking at the monitoring of each step a signal goes through from reception to transmission, or even to the off-air signals themselves, including the route the signal takes from process to process. The same can be said for file-based media, but in an OB, this is normally limited to slow-mo devices or video servers, both of which have limited signal processing and monitoring. So here we're talking about real-time signals. Traditionally, the tracing of a signal can be a long and complex process, normally involving a combination of using control panels to determine what the current status of the router is, and also system diagrams, assuming of course they're accurate. So here we can see the control panel is looking at line 2 as a destination on the router, and this panel is telling me Proc4 is its current source. Now if I look at the system diagram, I can see that line 2 is not the end of the process here. There is another step, this frame synchronizer, which this isn't telling me about. So I need to have a combination of control panel and system diagram to even give me the basic knowledge of how the workflow is travelling through my truck. Now to determine what Proc4 is being fed with, I need to make that the destination of this panel, and in this box here it will show me what the source is. So Proc4 is being fed with the mixer program. Quite a complicated process involving drawings, probably many drawings, and also continued use of a control panel. I think it'd be better that your operators were given a single go-to piece of software to show them what their workflow was. And one of the easiest ways of demonstrating the workflow is to use a flow diagram. And here we can see the flow diagram for line 2. The signal originates from the mixer and passes through Proc4 and this frame synchronizer. Now in addition to the information I could get from these two areas, I can also see what Proc4 is doing here. It's doing an HD to SD transition. So by using a flow diagram, I can give my operators a lot more information. But diagrams don't have to be limited to just information display. They can become control panels in their own right. So if this was a button, I could click on it and a little pop-up screen occurs. And on it, I can see the different transitions I can make Proc4 do. So I can make it do a different thing. And it's also showing me the video status and also the audio status of the signals passing through it. So a lot more information can be determined by showing this on a workflow. I would suggest that the design of these workflows always uses the same symbols and same colours to represent the same thing to the operator. This is going to remove any confusion and lead to a better performance and probably a quicker response to any issues developing within the truck. And while we're talking about the design of these panels, I suggest you get your staff involved at a really early stage. Firstly, so they get buy-in to the whole system, but also so their operational experience can be built into the design so that the whole thing gives a better response when it's called into action. So in conclusion, workflow monitoring is becoming widely deployed with users rapidly finding benefits from improved on-air quality and faster time to fault resolution. OB trucks already have advanced router control and tally systems, so why isn't more detailed monitoring installed in OB trucks now? If you want to share your experience in workflow monitoring, join the discussion on connectedob.tv or use the hashtag ConnectingOB on Facebook, LinkedIn or Twitter. Next time on Connecting OB, we'll be discussing how signal formatting and distribution can be simplified by using a tailboard router. Thank you for watching.